Hello everyone. Today we're going to look at this double integral question where the R, the domain, is given in x and y terms, where x square plus y square is greater than or equal to 1, less than or equal to 4, and where x is positive and or it is greater than or equal to 0, y is greater than or equal to 0. So this means both x and y have to be positive, and that happens in only one quadrant. So the quadrant we are dealing with has to be the first quadrant, and that's the case in this pictorial representation as well. So now, x squared plus y squared is less than or equal to 1. So this means it's outside this region, and is less than or equal to 4 is inside this region. And why is it so? Because x squared plus y squared is equal to, let's say, a number. This is the formula for circle, right? So since here it is less than or equal to 1, this means it's outside or beyond this, and this is x squared plus y squared. This surface, or like, this area represents a circle. So area under this is represented by x squared plus y squared is less than or equal to 1, right? Yep. So, but here it is greater than 1, so it's got to be outside, and this likewise is x squared plus y squared is equal to 4. This curve is represented by x squared plus y squared is equal to 4. Since it is less than or equal to 4, it has to be this. So the area that we are concerned with for this problem is this one, right? So now, for questions like this, it is always recommended that you change x and y to r and theta when you're dealing with circles, like similar kind of surfaces. It is recommended you change it to r and theta, and you'll see why it becomes much easier. So we know that x squared plus y squared is equal to r. So it's something like, this is the origin, this is something, like a circular curve. Then if this is r, then it's going to be x squared plus y squared under root. So r is going to be x squared plus y squared under root. R squared, on the other hand, is going to be x squared plus y squared. So the Pythagorean theorem has been used here, right? So now what we will do is change it. Change x squared plus y squared in terms of r square, right? So r square is going to be greater than or equal to 1, less than or equal to 4. But r, on the other hand, is going to be less than or equal to 2, greater than or equal to 1. So that's done. And why is theta greater than or equal to 0 and less than or equal to pi over 2? Because it's in the first quadrant. And first quadrant, this is 0 degrees, this is 90 degrees. In other terms, is equal to pi over 2 is equal to 0, right? So that's the reason why theta, the angle, right, is equal to or less than 0, pi over 2, greater than or equal to 0. So that now we've defined our domain, right? Now we've defined our domain. Now let's find the volume, because double integral represents volume. So again, 0, pi by 2, 1, 2. So this means since the limits 1 and 2 are outside, it's going to mean that dr, is going to be the outside, theta is going to be in, and why will we have r here? Why is it not just d theta and dr? So it is because, let me make a small circle, right? You have something like this maybe, and then let's say this, oops, this is not what I wanted. Okay, something like this maybe, yeah. Let's say we draw a line here, right? And then since we're talking about like very small area, then let's say it's something like this, and then there are multiple radii, and let's say this box is the one we're concerned with, right? If we're concerned with that place, then if you're trying to find the area of that, the change in area for this one, then it is going to be, so it is first going to be d theta, and let's assume that this angle, let me use a different color, right? This angle is d theta, so it is going to be d theta, but then d theta is, how is it going to be a part of an area? So we know for the relationship between theta and, the arc length relation, I think that is what it is called, right? So for that, how are we going to calculate it? That's another question, right? So the formula for that, I I hope you know because this is something we sort of do it in our high school, right? So it is so length of the arc in this case is this would be radius times angle. So if this is r, right? In this case, this would be r is r times d theta, right? So we have found this. It's very small, remember, it's not as big as this, it's really small. So this would be uh, r d theta, and this, on the other hand, since it's a small change in radius, would be dr. So that's how we get r d theta dr for the area of this. So it would be something like length times breadth in a way, because it's so small, it's nearly like a rectangle. But yeah, that's why we get r times d theta times dr, right? Yep, yeah. Let's erase this. That's extra thing. Right, okay. And so now this r multiplies whatever is in here. So we get r squared cos theta, r squared sine theta. So now see, we're integrating in relation to d theta. So r squared in this case would be a constant. That's the case here, r squared constant, and we've split the integrals. So what is the, integral of cos theta? It is sine theta, right? For sine theta, it is a negative cos theta, and it's from 0 to pi by 2. That's exactly what I've done here, 0 to pi by 2. And now we just input the value. Sine pi by 2 is 1. 1 minus lower limit. Sine 0 is 0. That's what I've done here. Cos theta. Sine pi by 2 is 0. Sine 0. Cos pi by 2 is 0. Cos 0 is 1. 0 minus 1 would be a negative 1. We already have a negative 1 coming from cos theta because integral of sine theta is a negative cos theta, right? So now that negative is going to be positive. R square plus r square, that gives you 2r square. 2 is a constant, gets out. R square, what is the integral of r square? That is r cubed over 3. R cubed over 3. Now let's put in the upper and lower bounds. R cubed, 2 cubed would be 8. 1 cubed would be 1. 8 minus 1, 7. 2 over 3 times 7 gives you 14 by 3. And this is your answer. So yeah, the only thing that you sort of have to understand is why theta is from 0 to pi over 2 and why r is from 1 to 2, right? Apart from that, pretty simple. No, nothing really crazy. And yeah, I hope you learned this and hope to see you in my next videos. Thank you.